All right, let's do the convolution of e of t and sine of t. So pretty straightforward with the definition up in front of us. So it is the integral from 0 to t of e of tau sine of t minus tau d tau. Okay, so we just need to integrate those. Alright, so nice integration by parts review. So this is where I'm going to go tabular method on us. So I'm going to take the derivative of e of tau, which is e of tau, and a bunch of e of taus. And then I'm going to integrate sine. So we start off with sine of t minus tau. And the integral of sine is negative cosine t minus tau times negative 1 because of chain rule there. So that's just cosine of t minus tau. And then integrate again. Sorry, I probably should indicate that what I'm doing each time. Okay, so if I integrate again, then I get sine of t minus tau, and that time it's negative because of the chain rule. All right, and so what does this all tell us? All right, so from this little chart I made, we can see that it is e tau sine of t minus tau plus e tau cosine t minus tau minus the integral of e, I'm getting off the screen here, minus e tau sine of t minus tau d tau. Okay, and so, okay, now I really am off the screen there. All right, so the plan is I'm going to take this piece and add it to this piece, and then divide by 2. Okay, let me clean this up a little bit, and then I'll show you what I'm talking. So I'm going to add the two integral pieces together. Okay, so you can kind of see that when I said clean it up, I brought the two integral terms together, so which put a 2, so I ended up dividing both sides by 2, and now I just need to evaluate at t and at 0. Okay, so if I evaluated at t, essentially I just get e of t over 2. I get sine of 0 plus cosine of 0, which is essentially 1. And then if I evaluate it at 0, I should just get sine of t plus cosine of t. And remember, I'm taking the top response, subtract the bottom response. So my final form there should be 1/2, and then sine of t, I'm sorry, let's do e of t first. E of t minus sine of t minus cosine of t. Sorry, I was just looking over my work here, and this piece right here, I said it, but I didn't write it. So 1/2 sine of t plus cosine of t. Okay, here, I will box my final answer. So there we go. That's the final answer. Okay, so to find the Laplace transform of the convolution that we just worked out, I'm going to remind you of what we just worked out. So the convolution of e of t and sine of t Just put a reminder there. So then we just want to find the Laplace of each term. So it's 1/2 the Laplace of e of t minus 1/2 the Laplace of sine of t minus 1/2 times the Laplace of cosine of t. And we can just go back to our chart and look at that. So that's 1/2 1 over s minus 1 minus 1/2 of 1 over s squared plus 1 minus 1/2 of s over s squared plus 1. And then I can just combine all of that together to a single fraction. So let's see, it's going to have a common denominator of 2. It's going to have an s minus 1 and an s squared plus 1. Let's see, so the first fraction was missing an s squared plus 1. Then we're missing, so minus 1 times s minus 1 minus 1 times s minus 1. Oh, I'm sorry, minus s times s minus 1. And then I just want to go through and make the numerator nice and pretty. So s squared plus 1 minus s plus 1 minus s squared plus 1. So the s squareds are going to cancel out. Oh, sorry, I just caught my interesting error there. So that's a minus s, or plus s. Oh, okay, so that means I got a 2 up top. S squared plus 1. So that final form then would be s minus 1 and s squared plus 1. Okay, and that's all they asked us to do at this particular moment. Alright, so as we've seen many times in this class, we learn rules so that we can get to more complicated things. So if I'm doing the Laplace transform of a convolution, I can actually break it up into the product of the Laplace transform of each individual functions, which in theory will make our lives a little bit easier as we start looking at examples here. So we've actually seen this example here, the integral of 0 to t e of tau sine of t minus tau d tau. So that's actually, remind us, the convolution of e of t sine of t. So using our new little convolution rule with Laplace transforms, that means I can find the Laplace transform of e of t and multiply it by the Laplace transform of sine of t, which is just 1 over s minus 1 times 1 over s squared plus 1, which gives us 1 over s minus 1 s squared plus 1. A little bit easier than what we did before, right?